And I just want to finish up with one other characteristic of the right angle, which is very important, is that the measure of a right angle is 90 degrees. Okay, so that is, we were talking about degrees earlier, the measure of a right angle is 90 degrees. Well, let's go back for a moment about the acute angle. Acute angle, as you can see, is smaller than a right angle. The angle measured between these two sides of the angle are less than the right angle here, and therefore the measure of an acute angle is between 0 degrees and 90 degrees. An angle which is larger than the right angle is an obtuse angle. This is an angle whose measure is between 90 and 180 degrees. Okay, so it's greater than 90 degrees, and that makes it a larger angle measure between the two sides of the angle. And why are we picking 180 degrees? What's so special about 180 degrees? Well, that is what forms a straight angle. So when you actually have an angle where the two sides are collinear, okay, so a straight angle is one where the two sides are collinear. You then have a straight angle, and the degree measure of a straight angle is 180 degrees. So we had 90 degrees for this one. We had less than 90 degrees for an acute angle, and we had greater than 90 but less than 180 degrees for an obtuse angle. Our last vocabulary word for today is angle bisector. An angle bisector is basically a ray that bisects an angle, or another way of saying that is a ray that divides an angle into two congruent, which is the same thing as saying equal, angles. So in this diagram here, to the right, we have an angle. We actually have several angles. Let's list the angles that we've got. The largest angle, going all the way from side CB to all the way to side CA, ray CB to ray CA. Okay, so the angle formed by ray CA and ray CB is angle ACB. Okay, the angle formed by ray CD and ray CB is angle BCD. Okay, so ray CD is this middle line going up and down there, this ray in the middle, and ray CB is the ray on the right side, and the angle formed with these two rays as sides is angle BCD. And finally, the angle formed by ray CD and ray CA, which would be this ray and this ray, is angle DCA. By the way, of course, we can also call this angle ACD if we wanted to. They mean the same things. And the same thing with these angles as well. We can come up with names that mean the same thing. Okay. So, in this case, we have something else in this diagram. These things are all true. What we've written down here you should be very comfortable with by now. If not, review the definitions. But we also have the angle bisector. In this case, CD is the angle bisector because the angle formed, the original angle that existed before we wrote in ray CD was angle ACB. Okay, that was formed by the outermost sides. By then placing ray CD in the middle, we have divided the original angle that existed, ACB, into two equal angles. One of them is BCD, and one of them is DCA. And the way we indicate that these are equal angles is by drawing a small line through each of them, an identical looking line through each of them, and that sort of mathematician shorthand for saying that these two angles are equal. So the measure of these two angles is the same. Okay, that's really what we're saying when we say they're equal angles. The measure, the number of degrees in each of those smaller angles are equal to each other, and each of them is equal to 1/2 of the measure of the original large angle ACB. So a related concept to all this is the angle addition postulate. So the angle addition postulate is very similar to the segment addition postulate that we saw earlier, okay, which was that if you add the lengths of two segments which are collinear and share a common endpoint, you will be able to add the two measures together to get the measure of the larger segment. And here we've got something very similar. We're going to be adding two smaller angles together to get the measure of a larger angle. So this is the angle addition postulate. If D, point D, is in the interior of angle ACB. Okay, so ACB is the outermost angle formed by rays CA and ray CB. And if point D is in the interior of that angle, which it is in this case, okay, D itself as a point sits between the outer twomost rays, then if we draw ray CD and create the two additional angles that we have here, what's true is that the measure of angle ACD, which is this angle here, ACD, plus the measure of angle DCB, which is this angle here, I'll notate that with two lines, and that's often two little marks rather. There's one mark for angle ACD, and there's sort of two marks for angle BCD. Then the sum of the measures of angle ACD plus BCD equals the measure of the larger angle ACB. And that is the angle addition postulate. And we will continue the lesson in the next video.